Do you feel Buckminster Fuller has found a key to the great comprehensive patterns of the universe? And if yes, in so doing, or attempting to do so, is he redefining our position in the universe?
I don't know whether he's found those patterns or not. I know he was seeking them. I know that he was more attuned to larger comprehensive patterns than most human beings, and it's given to most human beings to have the capacity to do. I think he was absolutely unique, and this betrays his reliance on technology. I don't think anyone has answered the question of what is the role in humans in the universe. He loved that as a title for his speeches. What is the role of humans in the universe? Why are we here? And I think his most explicit and simple answer is that we are here in the universe as local problem solvers. Well, I'm distressed because to most people, they don't know what he's talking about. That doesn't mean anything to them. And what he means is explicitly, literally, local problem solvers. There are certain things that nature needs to be done. And I don't know whether Fuller would say this or not, but I suspect that the example of we need computers. Computers perhaps could be created biologically. Eventually they may well be created biologically, but the creation of computers by human intervention is to me an example of humans solving a local problem. And that nature uses humans to do things that otherwise couldn't be done, which is another reason that Bucky eschewed the word artificial in any sense. If man makes it, it's natural, it's not artificial. If nature permits it, it's real, it's natural, it's not artificial. He never used the word artificial because there was no artifice. And for him, and he above all humans, had a mission for solving local problems. And he says the lovely thing about solving problems is the minute you solve 3 problems, you find that there were 6 more that remain to be done, and it's inexhaustible. And he defines truth in the same way, as merely truth for him is a tendency and never a resolution, because he's preoccupied with process rather than a static pattern. And all these different avenues, they sort of converge. Does that make any sense?
Yes, yes, it does. It is my understanding of Buckminster Fuller that he wishes all of humanity to succeed. We hear the term, I believe it is even in corporate levels, a borrowed term, a win-win scenario for all. To be sheltered, clothed, and fed so that we can all move on to a greater destiny full of fresh knowledge and new discoveries. Is this inaccurate?
That's an accurate
viewpoint
statement of his vision of what could be done. And in fact, he feels it was the only possible course. If we don't do this, we all fail. It's either that or catastrophe. So, and in a way, this anticipates a great deal of more conventional ecological thinking, that we have to reduce the enormous disparities in economic circumstances of the passengers on spaceship Earth in order even for the richest to survive. We have to reduce and spread the resources. And Fuller would argue that there's never any pain in that, because he said even a poor person here lives better than the kings in the past. The resources available to them that they now have a command of that were unthought of even 100 years ago. So people say, oh, well, he's just an incurable optimist. And he always denied that. He was never sure we're going to make it. He was an optimist. He was absolutely certain that we had a chance. He was certain that if we did the right things, we could make it. But he wasn't sure that we would. So in that sense, he was not an optimist.
I get the feeling Buckminster Fuller is a very impatient man, sometimes angry. He seems to want us to move on to the next phase of our evolution. I get this feeling from 50 years of writing and trying to edge us on to higher plateaus.
I don't know the answer to that, but there are two aspects of it I can comment on. One is he had exquisitely lovely manners with people, and only, of course, he would lose his temper like all of us. But he had generally very nice manners and very kindness. He was particularly good with young people. And his impatience manifested itself on questions of integrity. If there was some course, he would, to go into Union Station when it had been butchered by architects and was so inefficient, would cause him almost sick. And I've been with him in Penn Station in New York, and he'd go into that enormous men's room there, the one where Jacques Kahn, the architect, died, as it happened later. But there were about 30 or 40 male urinals, and he would go down and flush any that people hadn't flushed, because this was just is part of being civilized, how people should live together and making the system work. And when it didn't work, or when he would see bad design, bad architecture, it was an affront to his sense of integrity, and he would be very impatient with that. The second part of your question, if I understand it, is that he thought, okay, here we are in the latter part of the 20th century, and he was in a big hurry to get to the 21st or the 22nd century, somewhere like that. And my answer to that is that only those people in his family and those that lived close to him or really could hear him talk realize how, for a gregarious person who would love to talk and be with people, he was essentially very, very lonely. Because having discovered this vision of how the nature worked and his own cosmos, and finding so few people to share it with him, it was an enormously lonely life. And I suspect that if he were here to answer that question of, now he's in the 20th century, is he in a hurry to get to the 21st century or the 22nd century, I think he might have rebuked us for asking the question by saying it was too much of a preoccupation with the local phenomenon of time.
I ask that question because he seems to want us to move beyond local politics and even beyond biological urges.
I wouldn't. I think there's some validity in that. He wouldn't even discuss. He just says, "I am not political."
But isn't world gang the ultimate political?
Well, it's sort of, you see, like a city manager or the technocracy. There has to be some committee procedure. And when you get into his program for organizing economics and society, he never, and even education, he wrote Education, Automation, all of that, he never fleshed that out in the details that he did his geometry. And it's one of the reasons that I had a tendency to keep out of synergetics the sociological, political, and economic part, and he resisted that and felt that the books he wrote after synergetics were compensating for all of his economic and social philosophy that were not incorporated in it.
Why does Buckminster Fuller have to reinvent the world all by himself, from the English language to
because
the automobile?
He's acting for the rest of us, using our experience in. The answer to that, why he has to reinvent. Why can't he accept what everyone else has?
Yes, exactly.
And I tried to, and have a feeling for that in the first words of Synergetic, or in the before page 1 are "Dare to be naive." And he felt that our sophistication with all the cars we have and all the inventions we have, we're so preoccupied with them that we don't dare to be naive and go back to first principles and ask simple questions like, is something better than the car? So you say rejecting, reinventing everything. Rediscovering. He felt we were too much prisoners of our cultural circumstances and our cultural reflexes and our local habits and the way our PTAs operate and the way we run and manage things, that there are so many radical solutions that we're ignoring because we do not reinvent. And it isn't that Fuller has to reinvent, but he wants to illustrate how each of us can reinvent for ourselves. And that doesn't come through in so much of his writing, that so many of these assertions sound bombastic because he doesn't keep repeating that I'm just showing what any one of us can do. And so there seems to be a lot of first-person singular and egotism there, which he, when challenged, could very quickly dispel.
We ended yesterday, we mentioned, I think very partially, something about the Fullerines yesterday. And I'd be very interested in finding out what are they, and where did the name originate, and what are we looking at?
They are an allotrope of carbon. An allotrope of any element is atoms of that element in a stable configuration. And carbon, although it's not the most abundant element, it's the most important for life, it's the basis for all organic chemistry, has only 2 allotropes in the history of chemistry. One is diamond, where they're in a certain tetrahedral, octahedral conformation of carbon atoms, and the other is graphite, where they're in more of a shelf-like layer. And in the discovery of Buckminster Fullerene, they find them organized in a spherical, icosahedrally organized sphere, the shape of a soccer ball. It's not a pure icosahedron.
Where did we find these, or where we?
It's just the power of our new electron microscopes. They now think these pervade the world. They think they're probably in outer space. Matter of fact, Harry Kroto, who was in the University of Sussex, was in search for organic particles in space, and he teamed up with the people at Rice University in Texas, because they had the equipment. He was trying to get the equipment. It's very expensive equipment, and Rice has it, and he had the ideas, and so they collaborated, and their paper was published jointly, and published in Nature about 1986, I think it was, maybe later. Before this allotrope was discovered of carbon atoms forming themselves in a stable pattern, other than diamond or graphite, there had been some discoveries here at the National Bureau of Standards by a fellow named Schechter of aluminum manganese compounds, I guess they are, or molecules, organizing themselves in an icosahedral pattern which exhibits 5-fold symmetry. And these patterns do not conform to the classic classes of crystallography, which is a fairly mature discipline, and it's changed very little in the Encyclopedia Britannica over the last 200 years. And some systems have 6 classes of crystal symmetry, and some say 7. But in any event, they don't provide for 5-fold symmetry. It was one of the forbidden symmetries. And the reason that it has come in to dominate this last decade of chemistry is not because they were looking for it, but because they couldn't hide from it. And it wasn't until they invented telescopes that could get down to an almost atomic level of resolution that they discovered that there is five-fold symmetry in nature. And they weren't looking for it. And they didn't want to believe it. And they still find it very hard to conform to a lot of their chemical preconceptions. And this is sort of on the marginal, since it's down to an atomic level, it's almost on the threshold of physics, but it is a chemical pursuit, but it has certain implications for physics because of the properties of these molecules, which are have properties of conduction and many applications for lubricants and for vessels for, well, there's just a whole blooming array. It was the molecule of the year when it was found, and it is, at this moment, there are literally thousands of chemists for whom this is their chief interest. And so I was very interested in documenting this because and I knew about it even before it was named Buckminster Fullerene, because I've been watching developments in five-fold symmetry and that literature. Does that answer your question about what is Buckminster Fullerene?
Yes, it does. The scientific community talks very excitedly about this discovery. But does Fullerene just carry Buckminster Fuller's name? Because this is a new class of molecules that happen to look like possibly geodesic.
Well, it looked like a soccer ball, and then they could have called it saccharine. But then they called it Buckminster Fullerene, and a lot of the scientists object to that and still do object to it because they think it's trivial. Smalley likes it, who with Croteau named it Buckminster Fullerene, because it has exactly the same number of letters as the points on the soccer ball, because it's really a very short term considering all the meaning that it conveys, because the international nomenclature system for chemistry, the name of it is 6 or 7 lines long, and Buckminster Fuller is very short for that, Buckminster Fullerene. Now, they've recently adopted the use of fullerenes as a generic for the various forms of it. They're fullerenes, they're fullerides, and all the chemical variations of the other associations that come from this. But the pure fullerene is C60. And then there's C72. There are various symmetrical harmonics of arrangements, quasi-spherical arrangements of carbon atoms that are varieties of the Buckminster Fullerenes. And when I went down, as I did several years ago, to call on Smalley, sort of on behalf of the Fuller legacy and speaking for the estate, Allegra, and the Buckminster Fuller Institute, of which I was a director, and I wanted to say how gratifying it was to the family and heirs that he had named it for Buckminster Fullerene, but hastening to assure him that we were not making any claims to priority on Fuller's halves, because this is a precious and understandable about chemists and their very integrity of who found it first. And we weren't making a claim that he knew all about this and had discovered it first. The claim I did make to him was that Fuller's intuition, and one of the major themes of synergetics, is that nature organizes itself spherically and geometrically, tetrahedrally and icosahedrally in patterns of nature that are more valid than the XYZ coordinate system of Cartesian and calculus that most scientists are familiar with working with. So I said that just as Fuller didn't do his math so he could build a dome, he built the dome because nobody understood his math. And he says, if I build a dome like that beautiful dome in Montreal, everyone can see for themselves that this is a totally spherical coordination. You have to start with holes. No bunch of engineers could sit around a drafting board with 30 struts and ever just come up with the icosahedron. You have to start out with the idea and see how many struts do you need. And the parts are subordinate to the whole, and that's what's synergetic about it. So I suggested to Smalley and to Croteau, who's been very sympathetic about this, and Croteau, by the way, when he was very young, came and visited the Dome in Montreal as a young man, and was an admirer of Fuller and his works long before Buckminster Fullerene was discovered. And I met with him the last time I was in London, and I have a long correspondence with him and others in the field of fivefold symmetry, like István Hargitay in Budapest, and they are receptive to the idea that there may be intuitions of Fuller's that are relevant to their scientific work. But I have kept assuring them that Bucky didn't follow their rules. He didn't want to publish a chemical paper or an engineering paper. He was following his unfettered intuition. And it was that intuition that asserted that the role of fivefold symmetry anticipates the way nature actually performs, and this wasn't triggered until our telescopes got powerful enough to see that there were, in fact, these things materially manifest, that there was a great big breakthrough. And as for the future of Buckminster Fullerenes, quite aside from the practical applications, some people even go so far as to say that it's going to require a reorganization of the periodical table of the the periodic table of the elements, because it is on the threshold of an atomic and molecular threshold that doesn't, all the questions aren't answered by the periodic table. But I think even more startling and surprising and suggestive is the idea that all of our chemistry of the 20th century derives from the benzene ring, which was a hexagonal planar structure in which most all of modern synthetics derive from the benzene ring, a whole new field of chemistry, everything from rayon, the whole world of synthetics derives from that. And some of these chemists I talk to suspect that the two-dimensional hexagon benzene ring, what that did for 20th century chemistry, the three-dimensional spherical Buckminster Fullerene soccer ball may have a comparable impact on the chemistry of the 21st century with a three-dimensional rather than a planar model. So now I'm not a chemist, I don't know, I'm a science writer, and I try to be an honest reporter of what people say to me. And of course, this is a thrilling validation of Fuller's intuitions. And I like to think that on whatever cloud he's sitting on now, he can see this kind of confirmation from the most unexpected kind of quarter, because these are people that were not championing him. And they still, most of them, have the conviction that the naming for him was coincidental or trivial. And I think that it will be some time before scientists and other scholars recognize that there are aspects of synergetics of which this is only a physical manifest example, but there are further resonances of Fuller's intuition that might also have implications for chemistry, biology, and other disciplines of science.
So I get the feeling here that Buckminster Fuller was or is on the right track. Things are being confirmed here.
It validates that there are patterns in nature that conform to his method of analyzing nature when he rejected the Cartesian method. And he started out with his new radial circumferential coordination of a spherical geometry. And this is a particular persuasive kind of validation, because it shows up in the most exquisite kind of physical measurement that there's nothing mystical about it at all. This is just, it's physics, material science.
Do Do you think that maybe now, because of this new discovery, people will go back and look at synergetics?
Very slowly, very slowly. Synergetics is still pretty inaccessible. You've got to learn its vocabulary. You've got to start, and it takes an enormous span of attention. And all of the aspects of it have to be kept in sort of suspense. Bucky's last book, his valedictory work, Cosmography, that Kyoshi Kuramiya did such a wonderful job for 5 years, his lonely task of getting that all together. That text was a magnificent accomplishment. It hasn't received the critical recognition it deserves, except to its credit by some magazines like Nature, the very prestigious scientific magazine published in London, reviewed it seriously, critically, but seriously. In that book, Cosmography, Bucky has 100 pages of exposition of precession. Precession is the phenomenon that operates in a gyroscope, and it's a counterintuitive phenomenon. It's not a common everyday reaction like the lever. And Fuller maintains, and one of the themes of this book is that nature operates precessionally and not in the linear pattern of most of our models. And it not only operates that way physically, but it operates that way economically, socially, politically, historically, psychologically. And he says humanity will still be living in the dark ages until they realize that their model should be a precessional one. So just as the Buckminster Fullerene is a model in the physical world, precession is a model that Fuller advances for broader than just physical nature in its applications. And for the reader to read 100 pages of exposition of exactly how precession operates, and then keep that in mind while Bucky reviews all the historical forces. I think we better. Cosmography is that it has not been widely reviewed and widely received. It is a difficult book. And so I don't anticipate that there's going to be any quick breakthrough or recognition. I think all of Fuller's writings, not just Synergetics, will stand the test of time. They're consistent and they're original. And before we close, I want to get to...
You were talking about precession, 100 pages on precession. I'm having a little bit of a hard time here.
Well, so did Fuller. Precession is a very hard thing to describe, particularly without illustrations, because he has a lot of illustrations to describe it, the way a gyroscope operates, and the way that precessional reactions are reaction other than 180 degrees.
There is precession, if I believe, between the movement of the planets.
That's correct.
Around the sun. Could we use that model?
That's correct. And precession operates that way, but we're not familiar with its operation at a micro scale and in the affairs of men and in the ways of our consciousness that he thinks we should recognize if we really want to understand society. So that's a very inaccessible proposition, and it requires a great deal of concentration to understand, because in order to understand it, you have to suspend most of the reflexes and training of everything you're brought up with. You have to say that maybe this unusual way of looking at the world has some validity. And so I don't think it's going to be quick.
It's going to sound like I'm going back on what we've already talked about. But there's a few questions I just want to throw in the air, and we'll see what happens. If you feel that's been answered, we'll just pass. Doesn't synergetics outline and demonstrate the principles underlying this entirely new family of carbon molecule clusters? And that was the why of my question. Aren't people going to go back to synergetics, and maybe, I have a feeling that synergetics here did demonstrate some of the underlying principles?
As far as I know, it makes no specific reference to carbon cluster molecules. Most of its message is implicit rather than explicit, because its whole explanation of the material world of nature and energy, the patterns of energy in the material world, follow a geometry that accounts for such molecules as Buckminster Fullerene that are not accounted for by conventional geometrical approaches. I think that's fair to say. But I think it's going to be a very daring and imaginative scholar who can go through the pages of synergetics and see other avenues and might be pursued also. Because what synergetics is really about is a different way of thinking. People are very conservative about the way they think, and they are very reluctant to give up their patterns of thinking that they think have served them so well thus far.
So I mentioned earlier that Buckminster Fuller is probably on the right track. Can the burden of proof be finally alleviated from all those critics and cynics that nature's coordinate system is discoverable and knowable?
Bucky was very interested in proofs, and he got very upset when people said he wasn't concerned with proofs. He did not follow the orthodox procedures and methods of science in peer review and papers and measuring things, and he didn't discipline himself that way, although he had respect for it and he understood it, and he had respect for proofs. And he craves proofs, and he was very eager that posterity would accord him the kind of validation and proofs of which Buckminster Fullerene is only just sort of a harbinger or a symptom of what may be a validation of his theories. But I don't think that he will get the kind of proofs that your question suggests that you get on scientific questions. Because for one thing, there are two reasons for it that come to mind. One is we don't study geometry as a hands-on laboratory science. It's not in our culture, which is what he does. And second, he takes all the licenses and advantages of a poet, and his presentation is poetical. And we don't sit down and prove whether Tennyson's Mort d'Arthur or whether James Joyce or whether these things they're not susceptible of the kind of proof that science is. But Fuller is vulnerable in that regard because he takes as a stuff of his poetry and his creativity the language and stuff and phenomenon of technology instead of just abstract or aesthetic speculation. And technology involves the behavior of the material world, and particularly as it interacts with human beings. And since that's the arena in which his poetic imagination operates, the kind of proof is not going to be the kind of proofs that we're used to in the past.
So you wanted to make a brief expose of what you feel Fuller's greatest contribution.
Well, it's not so much that as I'd like to talk on what I think his less appreciated aspect of his record. Everyone knows that he was a Renaissance man and that his genius flourished in everything from choreography to geometry to architecture, engineering, every aspect of almost every kind of human endeavor. He triggered his imagination and his originality. But I think what is underappreciated is the fact that he had the determination, the compulsion to start in an absolutely new place. And this is what makes him so controversial and what makes him so fascinating to me was the fact that he totally rejected the cultural traditions, not just those of Western civilization. I mean, he had a lot of respect for algebra. He had a lot of respect for Democritus. But he felt that he didn't want to learn from books. He didn't want to learn from teachers. He wanted to learn from experience. Synergetics he described as EFM, experientially founded mathematics. The experience that's available to any human being who can see and touch and feel. And he found that the basic starting point for humans' encounter with the physical universe is geometrical. And it's geometrical in the shape of a tetrahedron. The very word tetrahedron is very off-putting to people. A tetrahedron, the simplest description of a tetrahedron is that it's a pyramid. Why everyone knows a pyramid? Because we know they're in Egypt and we know what they look like. A tetrahedron is even simpler than a pyramid because a pyramid has a square base. A tetrahedron has a triangular base, and it is 4 triangles together, and 4 faces and 6 corners is a tetrahedron. And a pyramid is really actually much more complicated. It's a half octahedron. Every time Fuller saw a pyramid, he saw the other half of the octahedron way down below the surface of the earth, because that was the only thing that made it a symmetrical figure to him. But he arrived at the tetrahedron and tetrahedral coordination on a great many different levels. I think one of the most poignant passages in Synergetics is where he tries to think of an infant in the womb or someone insulated from all sensory experiences, and you hear an event, either a ping of the sound or a touch on your arm, or there is an event. And you don't have anything to make it a reference to. And then there's another event, and you know there's 2 events. And then you still keep listening or looking or whatever you see, and there's a 3rd event. And only till you get the 3rd event do you realize that there's a sequence. And you have some measure of whether the interval between the 1st and the 2nd and how that relates to the interval between the 2nd and the 3rd. And Fuller argues that not until you have the 4th event does it lock into a geometrical resolution that you can cope with and analyze with. And in the physical world, there's no such thing as an absolute plane. That's only in abstract geometry. But in the physical world of nature, nothing is an absolute plane. And so you have 4 events, and they can't possibly be 4 in the same plane, and therefore you have a tetrahedron. And that's the genesis of his conceptualizing of the phenomena of nature and why thinking, which he described as a dismissal of irrelevancies, is inherently geometrical. Conceptuality is geometrical. And it starts at that simple place of what he called getting nature into a corner. Now that is such a radical idea, and that is so remote from all the tradition of geometry and arithmetic of Western or any other culture. It's rational, it's not occult, it's not mystical, it's experimentally founded, and it's on the basis of experience. And his consistency on developing from that point his whole elaborate approach to how nature and how energy operates in nature comes from that point. And anyone might have come up with that idea, but very few of us would have had the self-discipline to adhere to that idea with such a commitment that he dismissed all the other reflex tools, references, the XYZ coordinate system, the Cartesian grid. He said, well, we got to the moon on it and it works. But man opened the wrong door to the universe. We opened a square door of the XYZ system. And that's not the way it works. And we can trick it around with, especially now with computers. Computers have compounded it so that the more irrational and the crazier and more contrary to intuition our mathematical tools are, the computers can handle them. And so in a way, that was something counterproductive about the introduction of computers, because they can compensate for our crazy mathematics as he saw it. But I think that the chief area in which he has not been recognized is the sheer courage, drama, originality of basing his entire system from a new starting point.